everyone. Thank you for joining our webinar, as we like to call it, of the Public Health Reporting Initiative. So today we have a couple of expert speakers in the field. We will kick off with, actually, first we have Anna. Are you on the phone?
Yes, I am.
All right, Anna, I'm going to run through the agenda real quick, and then if you'd like to give a brief introduction to Austin, we'll get started. So on our agenda today, we have Austin Chrysler from SAIC, and he'll be giving us a bit of an overview of the HL7 basics of 2.x messages. We'll have Keith Boone from GE talk a little bit about CDA and how structured documents differ from messages. And then we'll have Karen Whitting from IBM talk a little bit about the transport implications when choosing between version 2 messaging and structured documents. So we'll follow up those three presentations with questions and discussion from our membership. And we'll go ahead and jump right in. So Anna, could you introduce Austin for us?
Just would like to introduce not only Austin, but not interrupt the presentation during the hour. Just would like to thank Austin Chrysler, Keith Boone, and Karen, who have been working with us in several initiatives, including HL7 and IHE. And to me, they are the true experts in the topics we're discussing today. I cannot wait from them to hear how they can help us to better understand the directions that this initiative should go. Austin, Karen, and Keith, maybe you can introduce yourself as you begin your presentations. Thank you very much again for participating in this presentation session on such short notice.
Just want to say, for those wondering why our typical biweekly discussion suddenly turned into a webinar, we discovered that a number of our initiative participants, including those involved in the implementation specification working team, wanted to hear more detail about the differences between different approaches to information exchange, thus this webinar. Thanks very much for participating.
Hey, Austin, the floor is yours.
Okay. Well, thanks, Anna, for your introduction there. I'm Austin Chrysler. I work for Science Applications International Corporation. I'm a technical fellow, but I also wear a lot of other hats at HL7, including I'm being chair of the HL7 Technical Steering Committee. I'm a co-chair of the HL7 Structured Documents Work Group. And for my day job, I'm a consultant at the CDC for the National Healthcare Safety Network. I've been working in the HL7 field for many, many, many years, doing standards development, and have a background both in 2.x messaging and CDA and version 3 messaging, so I can actually talk about most of the HL7 standards. But I'm here today to talk to you about HL7 2X. Let's go on to the next slide. So, actually, this is a chopped-down version of about an hour-plus tutorial I can do about 2.x. So we'll be going through some of this fairly quickly. HL7 version 2X is a transactional-based messaging standard. There are transactions that are govern the exchange of information between two parties and carry out activities related to healthcare. The transactions are often tied to specific types of healthcare-related workflow management. Examples include orders, lab resulting, specimen management, emission discharge transfer, etc. Version 2 has a long series of versions that are associated with it, starting with the first really published version is 2.1, and then you have 2.2, 2.3, 2.3.1, 2.4, 2.5, 2.5.1, 2.6, 2.7, and most recently, earlier this year, we published 2.7.1. HL7's balloting version 2.8 right now. It's going through its second round of normative balloting, and HL7's accepting change requests for version 2.9, and I fully expect there to be a HL7 version 2.10. And so there's no sign of 2.x stopping anytime soon. There are way too many implementations of 2.x out there. It's widely implemented in the U.S. and in many countries around the world. In the U.S., up until fairly recently, and perhaps even today, 2.3.1 is probably the most commonly implemented version. I think that's shifting in the U.S. They're beginning to shift to 251 because of meaningful use. Let's go on to the next slide. So HL7WebinarFinal covers a broad array of types of messages. So I'm going to go over a number of these in brief. It covers patient administration type messages, including admission, discharge, transfer, sometimes called ADT data, messages for identity management, merging of patients and patient records, etc. There is a whole set of messages around order entry, managing order information, including clinical orders, laboratory orders, pharmacy orders, imaging, blood bank, supply, diet orders, etc. So there's a rich set of transactions in the ordering space. There's a whole section of the standard that deals with querying for information between systems. That includes querying for ADT data, orders, results, etc. There's a whole suite of messages around financial management that for transmission of charges, patient account management, etc. Then there's a whole set of messages around observation reporting. There are general clinical observation reporting, specific laboratory data reporting, imaging reporting, point-of-care results, etc. Let's move on to the next slide. Continuing with the types of 2.x transactions, we have a large set of master file messages which do deal with essentially transferring metadata. But anyway, there's a set of master file transactions which include things like exchanging information about staff or practitioners in the facility, location information, task catalogs, order catalogs, charge masters, service item masters. You can also exchange information about vocabularies used, all sorts of different types of master files that systems need to exchange to interoperate. So there's a whole set of transactions around that. There are a suite of transactions around medical records transactions, where including management of documents, and this happens to be one of the areas where 2.x fits in with documents, CDA documents. You can use a 2.x medical record message to actually transmit a document, and that's actually done in many systems. There's a whole set of transactions about scheduling, for appointment management, resource scheduling, etc. And then there's quite a number of other domains and sets of messages within 2.x that cover patient care, patient referral, laboratory automation, personnel management, and application management. And so there's just a huge set of different types of domains that are covered within the 2.x set of standards. So let's go on to the next page. HL7 messages are based upon trigger events, and those trigger events are associated with particular message structures. The trigger event identifies the action that caused the message to be sent. So that ranges anywhere from somebody enters a laboratory order, which has an associated trigger event with it that causes the order to be transmitted, and that order is transmitted via a particular message structure that identifies the payload associated with that trigger event. In many cases, the same message structure can be used by multiple trigger event types. So let's go on to the next page. So the basic structure of an HL7WebinarFinal message, you have your message, which is the atomic unit of data transferred between systems. Next slide. The messages contain segments, which are logical groupings of data fields or data elements. Next slide. Fields, which are contained in segments, and fields are strings of characters with an assigned data type. And next slide. And you may have, depending on what your screen looks like, you may have to scroll down to see the rest of this. Data types are basic restrict contents of a data field. Next slide. And finally, data types may have components and subcomponents, which are, these are strings of characters not intended to be further subdivided. So that's the basic structure of a message. Let's go on to the next slide. An HL7 2.x message is a collection of segments. All HL7 messages start with a message header segment called the MSH. And you can think of an MSH as an envelope with the addressee and return address information and some other information in it. But it's basically there for helping you route a message and understand what is contained inside that envelope. Within the message, HL7 messages, the segments can repeat. They can be optional or required. Segments can also be formed into groups of segments. Those segments, obviously, as I indicated, contain fields, which can be thought of as data elements. Fields can repeat, may be optional, required, or conditionally required. And each field is assigned a specific data type. And those data types can have components and subcomponents. So let's go on to the next slide. What are segments? Segments are groupings of related data elements. All segments have a 3-character code called a segment ID. And common segments found in many messages include the message header, MSH. It's always the first segment in a message. The PID, which carries information identifying a patient. And, for instance, a PV1, which identifies patient visit information. Those are extremely common segments in a large class of messages you find in 2.x. So the name of the segment sometimes gives you an indication of the type of data in the segment. Not always, but very often that's the case. So let's go on to the next slide. This is an example of a segment. It's an OBX observation result segment, and it's used to convey a particular observation. Let's go on to the next slide, and we'll dissect some of the pieces of this. So the first part of it is the segment identifier. That's that OBX, those first 3 characters, is the segment identifier. The next slide is the field delimiter. In this case, it's the vertical bar. And so that tells you right off the bat that in a 2.x messaging, we're using delimiters to separate pieces of the message. In this case, the vertical bar is used to delimit the fields within a segment. So you can count the field numbers by counting the delimiter. And so the OBX doesn't count as that set of 3 characters. OBX does not count as a field. The first field is that digit 1 following the first field. Okay, next slide. And here I've circled all the various field delimiters in this particular segment. Finally, the segment itself is terminated with an ASCII 13 carriage return character. That indicates the end of a segment, and then you can expect to either have the end of the message after that or another segment, which would be starting with a 3-character code. So let's go on to the next slide. So next, data types are, again, the basic building blocks used to construct or restrict the contents of a field. There are 2 categories of data types in 2.x. We have primitive data types which have no substructure. And although they have some sort of descriptive properties that tell you how to use the primitive, but complex data types, which are actually composed of primitive and complex data types. Let's go on to the next slide. We'll see an example of a complex data type. Okay, there we go. Actually, these are some examples of various types of data types. Primitive data types include string and text, the ST and TX data types, which just contain string or text data. ID and IS, which contain simple coded data. NM, which contains numeric data. DT, TM, and DTM, which convey date, time, or date-time information. Some complex data types include the XAD, which convey addresses, XPN, which is used to convey names, XTN, which is used for telecommunication addresses. That actually covers telephone numbers, web URLs, email addresses, things like that. The CE, CWE, CNE, complex coded data. CX, CN, and HD data type convey types of identifiers, and the PQ data type handles quantities. This is just a small subset of a wide variety of data types that HL7WebinarFinal has, but these are perhaps some of the most common ones that are found in virtually all segments. So these cover a lot of what you see in use. So let's go on to the next slide. This is an example of one particular data type called the CX data type, extended composite ID with check digit. So let's go on to the next slide here. We'll look at the pieces of it. First of all, we have the field delimiter, so that is inherited essentially from the message, or from the segment. Next slide.
Sure. Hey, Austin, I'm going to go ahead and give you your 2-minute warning.
Okay. We have component delimiters, which are, in this case, the caret, and the next slide, the subcomponent delimiter, which is an ampersand, gives you subcomponents within that. So that this particular data type has all the components and subcomponents, and so unlike segments, there are no data type identifier in the instance using the traditional coding of 2.x. Let's go on to the next slide. So HL7.2x in vocabulary, 2.x supports coded data via several data types, including the IDIS data types, the CE, CWE data types handle more metadata associated with coded data types, so you can carry descriptions and coding systems and translations of the code. And with the CWE, you can convey original text as well. Next slide. So 2.x and standard vocabulary. Certainly 2.x supports the use of standard vocabulary such as Lawrence Nomad, ICD-9, RX Norm, etc. HL7 itself does not require the use of those vocabularies in its base standards typically, so you won't find it in the base 2.x standard, but you may find particular implementation guides reaching out and using terminology such as Lawrence Nomad. Next slide. So that brings up the question of 2.x implementation guides. 2.x implementation guides find specific use cases to specific 2.x versions, messages, and trigger events. Those IGs typically provide additional constraints on the elements of one or more messages to support particular use cases, and those 2.x constraints are gathered together and called a message profile. Let's go on to the next slide. And actually, the standard has a fairly precise definition of what constitutes a message profile. So the types of constraints that you can do within an implementation guide include usage constraints, which constrain the optionality of the elements, cardinality constraints, so you're putting some sort of limit on repeats within a particular element. Data type constraints, you may be constraining uses of particular components of a complex data type in some fashion. Vocabulary constraints, so you may be picking value sets for particular coded elements, for instance, and then general conformance statements, which provide some sort of testable statement that the message sender or receiver must comply with. Next slide. Other IG considerations. 2.x IGs in the U.S. are frequently based on 251 due to government regulations and mandates. Use cases handled by a particular IG often require features from newer HL7.2x versions like 2.6, 2.7, 2.7.1, 2.8, etc. So often those 2.x IGs almost always pre-adopt features from a subsequent version and essentially retrofit them back into 2.5.1. This is called pre-adoption, and it's a commonly used feature these days in doing an ID. Next slide. So, issues with 2.x messaging. First and foremost, 2.x is an ad hoc standard. That means there's no formal data model behind how data is represented in 2.x. It's grown organically over the past 25 years. New stuff is typically bolted on at the end of the various elements of the standard. There's often overlap between elements of the standard, and sometimes documentation of the parts of the standard is pretty poor. And the standard provides multiple ways of doing the same thing, which causes endless grief for implementers. Next slide. And that's it. Anybody have questions?
Actually, I think we're going to hold questions to the end of the presentation.
Okay.
Thank you again, Austin, for that helpful overview of 2.x. With that, we will move on into Keith's presentation. So, Keith, are you ready to go?
I'm ready to go.
All right. Floor is yours.
Okay, so I'm going to take a slightly different approach than Austin did. I think most of the people who are probably listening are pretty familiar with HL7 standards. I'm going to be talking about this from the perspective of the HL7 critical document architecture, and looking at this a little bit in light of what you're trying to do with Public Health Reporting Initiative and the SNI framework. From a public health reporting sort of perspective, the things that I think about are the things that sort of show up in meaningful use. Electronic lab reporting, immunization, disease surveillance. We've also got birth and death reporting. I guess the politically correct term these days is healthcare-associated infections. And there are other kinds of public health reporting, for example, cancer registries. For a lot of this reporting today, it uses HL7 version 2 messages, which Austin just talked quite a bit about. In terms of those messages, there's essentially, I think, sort of three different components of the messaging infrastructure. There's transport, how the information's communicated. Does it get there via TCP? Does it get there via FTP? Does it get there via an upload to a file drop? However does the information get there? And I'm not going to touch on that at all. I think Karen Winning's going to cover some of the issues around transport. HL7 version 2 has some of transport built in to its messaging capabilities. Another piece that is somewhat built into the HL7 version 2 messaging capabilities is, what is this kind of thing that you're being sent? This is a VXU, an unsolicited vaccination update, or an ORU, an unsolicited observation message, or an ADT, an admission discharge transfer message for a specific kind of trigger event. So what's actually happening? What function are you sort of being expected to respond to, or perhaps even in the messaging framework perform? And then the last is, here is the associated content for the communication that is being used for public health reporting. And that's where we spend, I would say, most of our time focusing on. What is the content that we need for electronic laboratory reporting? How do we encode the lab test that was ordered or the result that came back? Or if we were talking about, say, a pathology test, the microbe that was detected and what it's sensitive to, what sorts of vocabularies do we use? So we focused content we're focusing on, those data structures that we're communicating for EOR, for immunizations, for disease surveillance. These are actually snapshots of the information as the information system that is reporting them is aware of them. So instead of saying, well, there was an update to record number 37 and this column was set to this value and this record, or this column was deleted, what's actually happening is it's just giving an update, a snapshot of what sort of information was available at the time that the report is being made. Now, that's interesting from a content perspective because a CDA document is a snapshot of the world in time. So it captures a record of what's happening in a particular encounter. So if we look at electronic laboratory reporting and we look at that as being a record of a lab test being performed, or an immunization reporting as a record of an encounter where an immunization was given to a patient, or disease surveillance as a record of an encounter where there's something pertinent to disease surveillance that's happening. The CDA documents are actually snapshots of the report-specific content that's being communicated. And there's a common set of data associated with that in terms of things like the patient identification, the facility where the information's coming from, the provider that is performing the services and is reporting on the specific activity that's going on. There are a lot of common instructions or patterns that are followed in this. And then as you get into specific kinds of initiatives, maybe some specialization of that content. So if we get to the next slide here, does this sound familiar? I certainly hope this sort of approach does sound familiar when we talk about starting from a common core data set and going to report-specific content and then perhaps initiative-specific content. If we look at what we've been doing over, the past 5-6 years, even going back before meaningful use, we look at the work that was being done in late 2009 by Andy Hixby in developing C154, which was a data element dictionary, C83, which was a set of sections and entries for CDA that could be reused, but basically describing a common core set of elements and CD vocabulary that was a consistent set of vocabulary. And of those three pieces of the common core, only the C83 component was specific to CDA. As a matter of fact, C154, approximately the last third of it comes straight out of HL7 version 2 messages. Then you look at report-specific content, and I wish I'd included one of the HITSB specific constructs that deals with immunizations. There's actually a document construct that deals with immunizations, which I will also talk about a little bit later anyway. But there are specific kinds of reports that put these pieces together in terms of content, basically arranging the different sections. And so you can have report-specific content for, say, a lab report, or for dealing with immunization reporting, or for reporting about a specific kind of encounter where there might be some information specific to surveillance going on. You could do that in a CDA document just as easily as you could do that in HL7 version 2. Now, CDA and HL7 this material now, and we have several different initiatives going on. We even have some initiative-specific content. The NWN has a specific implementation guidance that they use over and above the C32. Coming out of the work originating in Shiny and now including, I think, 14 states and 8 EHR vendors and a whole bunch of other different participants from the EHR interoperability work group. Now there's additional specifications that they're using on top of the C32. So if we go to the next slide and look at where we land with this today, now we're looking at, in the S&I framework, a clinical element data dictionary, which is actually based on the HITSB C154 specification, and is informed by current activities going on in the S&I framework. The report-specific content that is being developed now, we're looking at things like the CDA consolidation guide, which pulls together 9 different document types that came out of the HITSB work. And in that 9 different document types, the set of sections that are used, an example document type that was in HITSB was the immunization content, which is just about everything that the immunization registry wanted to know about an immunization or vaccination that had been performed, and the patient, and all of the other clinical data that was necessary. All of the sections that are necessary to do that are actually contained in the CDA consolidation guide. There's some work going on in HL7 to create a new document type that would fit into that CDA consolidation guide document type that would basically replace that immunization content and is functionally equivalent to the VXU message.
Hey Keith, I'm going to go ahead and give you your 2-minute warning as well.
Okay, so if we go to the next slide, just quickly, in terms of talking about whether you're going to go with a document versus a messaging approach, there are, so this is a perma thread on the internet. It's a philosophical issue that goes back to the 1970s. If you want to look at some good articles comparing the 2 different ones, there are actually links in this presentation. We will go ahead and look at those. According to HL7, there are 6 characteristics of a document, and the way I listed these out, the 3 characteristics on the left-hand side: persistence, stewardship, and human readability. Those 3 characteristics are characteristics that I would maintain are characteristics that are unique to documents versus messages. It's not to say that messages cannot have those characteristics. It's to say that from a CDA perspective, it's designed to have those characteristics, whereas messages typically are not designed to have the characteristics dealing with persistence or with stewardship or with human readability. All of the other stuff, context, potential for authentication and wholeness, that can be something that can apply to either. If we go to the next slide, real quick, we've demonstrated, going back, I would say about 5 years ago, the ability to do a dual approach where we would have an outbound vaccine update coming out of an information system, and it could come out in the HL7 version 2 format, could be converted to a CDA document and sent to a health information exchange so that you could use your patient portals and all of the technology and capabilities that you have in terms of exchanging documents to make them visible. On that inbound side, we also demonstrated the ability to take that same immunization content, convert it to the inbound VXC message, so that it could work with existing IIS systems, so that you could actually have a way for for health information exchange and an IIS to coordinate and work together. More recently, and actually going into implementation in a couple of states now, are abilities where you can query for a particular immunization, they call it a yellow card or immunization record, where that actually gets turned effectively into a VXQ message, and the resulting report back gets turned into a document dynamically in real time. So building off of an existing infrastructure, you can move towards a document-based infrastructure. And the key advantages of actually being able to do that are, because a document's just content. It's independent of transport. It's independent of what you're maybe trying to do with the messaging. It's not like you're saying there's been a vaccination update. It's you're saying at this particular point in time, we recorded information about a vaccination, and here it is in the document. And you can do with it as you will. So you're separating the components of transport, of messaging, or sort of the dynamic behaviors in the actual content. So you'd get that. And you'd be able to reuse a lot of the same content. You could take, for example, your essentially your summary care record information coming out of systems that support meaningful use stage 2, and find in that the information about the vaccines given, and use that in, say, an HIE scenario, where the HIE would get the records, be able to share information about that particular encounter, but also update the immunization registry with, oh, here's the vaccines that were given during this new visit that we just heard about. And so you have a mechanism by which you can transition to a document-based sort of orientation for your reporting and for your management. I think the last point that I would make is if you look at what's the work that was done with the cancer registry report, that report as well, I believe just about all of the sections, save 2, in that report are already in the CDA consolidation guide. So again, the same kind of work that is being looked at in other places for taking an existing encounter report and simply reusing it to support public health's needs is enabled by this approach.
Great, thank you, Keith. So with that, we'll again reserve questions until Karen's finished up with her presentation. Karen, are you set to go?
I am.
All right.
Hopefully you can hear me.
We can indeed.
Okay, I'm Karen Whitting. I work for IBM. I've been involved in several things of very detailed involvement in the IAG-ITI domain. Also involvement in a lot of the projects and initiatives under the NWHIN, including the Exchange, Direct, and several S&I initiatives. So I've kind of been all over the place. So if we want to go to my single chart, I got everything onto one chart. So, going on the left, you see I have content, some arrows, and then transport and some arrows. There's not a clear line between content and transport. Many people think there are, and in some cases I find that people debate where the line actually exists. So I'm kind of putting a blurry line there. And what I chose to do is I kind of took your 2 content standard, which is kind of HL7V2 message content and CDA, and I looked at what I thought was the most common, quote, transport approaches to moving these things. And I restricted myself to push technology, so I'm thinking only that I have something that I need to send somewhere and I know where it's going. That's kind of a push technology. Of course, there are other ways to do things other than push. So that's the top columns, my 4 approaches. The first one is HL7 V2 messages sent using a protocol called MLLP. And if we start at the bottom, we see that the transport, the lowest level transport that I described is TCP/IP, and all of these things have that in common. That's the fundamental part of the Internet. There are many protocols underneath that, by the way, that we will not be discussing today because that is seriously in the weeds. And then in the first column, we see that we definitely all agree that MLLP is a transport. But and at the top, we all agree that coding of the value, coding of values is probably content. You know, that's not transport. But the actual message, and you saw a description of the message earlier today, actually has some transport access into it, because the header actually says where this is going and some information about the message that is kind of maybe transport. So that ASCII message is what I wrote here. That's the actual coding that you saw earlier today. It's kind of intertwined a little with transport. The other piece of transport that's, I think, transport, but some people might not think it, is the actual encoding or security of the message, which usually is SSL or TLS. So that's the standard coding stack of a V2 message transported using MLLP. And I would say at the very bottom under the black line, I kind of talked about 2 kind of aspects of this approach, one of which is, do we see implementations of this? And of course, we all know that is pervasive. V2 messages over MLLP is a pervasive implementation. We have many testing things, one of which is IHE, and I assume there are other kinds of testing mechanisms out there. I don't personally know of them. So the rest of my talk is going to be finishing the 3 columns I haven't talked about, so let's go to the next one, which is HL7 V2 messages sent via direct. And for those who don't know, direct is a project that was initiated by ONC as part of the NWHIN. And direct is actually just email. So again, we have the top of the stack is the same. We have the value coding, clearly that's content. The message, and I don't really know how they take the message or which parts of the message they would take to do this. I don't know if that's transport or content. Again, it does need to be encoded. The S-MIME is what's used in direct as an encoding mechanism. And some people might think that is content. Some people might argue it's part of transport. I really don't know. Clearly part of transport is SMTP, which is the actual protocol used for email. And at the base of everything is TCP/IP. In terms of implementations, I have spoken to many people who say this is done all the time, but I've never spoken to anyone who says, I have done it. I don't know if it's interoperable. I don't know if any actual interoperability testing that tests this in a semi-formal way or a formal way. So that one is a little blurry for me in terms of its adoption. But I have heard a lot of people saying that it's trivial and easy and very obvious. So I just haven't talked to anyone who actually did it. Going to the next column is, now we're talking about the CDA documents. And so I have defined 2 ways of transporting them. One is, again, using direct, and then I'll talk about the last one when I finish with direct. So again, we have value coding, which is the coding of the values in the data set, and clearly that's content. And CDA is pretty clearly agreed that it's content. I think everyone kind of sees that as content. CDA, by the way, is coded in a standard known as XML, for those who don't know. And then, of course, you need some encryption in order to protect it. And again, direct uses S-MIME. Yeah, I think some people would see that as transport. Some people would see that as content, so I kind of put it in that fuzzy area. I don't really know if it's transport or content, a little bit of both. And then clearly part of transport would be the SMTP, which is email, and we have a common foundation. So the last one, I thought just going to the last, the implementation of that I think is growing. I think it's well understood. I don't know of any formal testing of it, but I do know people who've done it and not had any problems. So I do believe that one is growing, but does not have a formal testing process that I know about. I have a feeling it will be coming, though. The last one is CDA with XDR. And this one has the deepest stack, which is what, some people complain about the deepest stack and other people say a deep stack is value. So I don't know. It depends on your point of view. Again, you have CDA with the coding inside the CDA and the CDA XML. That's clearly content. What CDA with XDR adds is metadata. And I find it very interesting. Some people think of metadata as part of the transport. Some people think of it as content. The metadata supplied in XDR, A, helps you understand the content, and B, helps you know what to do with the content once you get it. So is it transport or is it content? I really don't know. But anyway, it's there, and it's something that the other approaches don't have. Then XDR, which probably shouldn't have been in there, basically the standard is EBRIM, which is the mechanism that we use to kind of package it up and get it from A to B. And again, I don't know if that's transport or content. Various people have different opinions about that. Below that is HTTP SOAP, which is clearly transport, and then of course our common base. I do believe there are quite a few implementations of this. We can see that with through IG with the registration and connectathon testing, and there is formalized testing of this within IG. So that is all that I came up with to say, so I would welcome, I guess now you're allowed to ask questions.
Great, thank you, Karen. So with that, you've heard our presentations from our three excellent speakers, and thank you again for joining us to share your thoughts and your information. At this point, I would like to open the floor for questions.
Hi, this is Tom Sherman-McCurl from the Immunization Safety Office at CDC, and my question's for the gentleman that gave the presentation on documents. And could he just explain what you mean by what is persistence and what is stewardship? And I assume readability means something you can actually read as opposed to an HL7 message, which you can't really read. But if you could just explain what those three things mean, I would appreciate it.
Persistence deals with the idea that this is content, this is information that there's a medical legal record is something that you're going to need to deal with for a long time. So part of the design of the standard is the idea that this is something that is going to need to be accessible for quite a while. It's going to hang out. Your content is something that is going to be preserved as a piece of content, as opposed to being sliced, diced, disassembled, maybe stored somewhere. And then as a piece of original, it can serve as a record of what was communicated. So that's one of the components of that persistence. The stewardship is, so if you're dealing with a document, especially a medical document, you're going to have an organization that is responsible for maintaining a true and original copy of that particular information. So in terms of the CDA, the clinical document perspective, the steward of the document is recorded inside the document. That's who you can go back to say, hey, we got this from you. Can we get a true and original copy of this particular document? So those are two of the characteristics of CDA that in terms of dealing with a reporting scenario could be useful properties for reporting that's being done, and which are characteristics that are not designed into systems of messaging.
This is Austin. The CDA standard asserts that those are characteristics of a document, and that those who intend to use documents need to follow, adhere to that. Messaging 2.x messages could have those characteristics as well, but the standard itself is silent on whether or not you need to do it. And that's one of the big distinctions, is that CDA is not silent on that. It says this needs to happen.
Okay, great. Do we have any other questions from membership or any of our colleagues?
I'm David from the wonderful world of HAI. So for all three of you, I guess my question would be, given the purpose of this working group with all the stakeholders representing the different stories, does it make more sense that our focus should be on the implementation guides rather than on looking to define an HL7 versus a CDA convention? Or is there any merit at all in saying there's a single HL7 or CDA format that should be the convention? Or as a third possibility, there really is a range of things, the basic minimum that everybody should be achieving and the ultimate goal that everybody should be striving for?
So this is Keith. I'll strike out first here and say, in terms of the communication approaches, we have sort of the traditional HL7 version 2 approach that we've been doing with its own set of implementation guides. Some of the newer work has been looking at taking advantage of capabilities that are being built into EHRs for clinical care in terms of communicating CDA documents and saying, let's reuse those for public health. Let's use the same capabilities that are being built into these products when being prepared and take advantage of those capabilities for dealing with public health reporting. I would very much like to see this work group focus on the kinds of content that it would need over and above what perhaps shows up in a CDA document today to deal with public health use cases, and look at, let us take advantage of these capabilities in terms of CDA. Look at CDA as being potentially a way forward for dealing with the content, and then just move beyond that into, okay, so what kind of content do we need as being maybe the focus of where your work would go. I think the big challenge there is there's this large investment in HL7 version 2 messaging that I think is scary for a lot of people to think that we can into CDX. So there's a lot of exploration that would be needed for that.
Yeah, I would have to agree with Keith on that. One of the attributes of HL7 messaging is that, of 2.x messaging in particular, is that the purpose of a message is very much tied to the type of events that you're trying to communicate. There is no one-size-fits-all HL7 2.x message. There's one that kind of fits there. That's the old ORU R01 observation result message, but that's not appropriate for conveying an admission record. But you know, it meets a lot of reporting cases, but it doesn't meet all of them. Whereas CDA comes much closer to being a one-size-fits-all because it can handle a variety of clinical data beyond just reporting observations. And so it depends on the whole set of use cases you're actually trying to grapple with. If mostly they're about reporting of a variety of clinical data, CDA tends to fit that much better. But if it's about operationally managing workflow, it's not necessarily the greatest fit. But then you've got to look at a variety of 2.x messages that may be more specialized in what you're willing to implement. I know in public health there's a lot of 2.x implementations, but they tend to be extremely narrow in looking only at the ORU. except in some cases where you're dealing with immunization, there's another narrow set of messages that are looked at there, and if you're doing laboratory messaging between public health labs, you may be exploring looking at using order messages, but in fact, for the most part, most public health implementations don't look at the full breadth of 2.x messaging, rather they're looking at very narrow slices of it.
This is really Brian Terrace from Washington State Department. I get a message. I like all three of you to kind of react to a question all three of you could react to. And I think I know where Keith and Austin will stand on this, but can you guys describe to me what you would say to public health epidemiologists or practitioners who have concerns that as we look to utilizing CTA and specifically the continuity of care document or this new consolidated approach, that what's included in the document or the message is a lot more data than we've ever received before, and that there are concerns that we're getting too much information or more than we're allowed to receive. For example, if we were to look at utilizing these to receive laboratory reports, there's a lot more than just the laboratory report embedded in the CCD. And do you have any reaction to how our partners feel about that, or tools for dealing with the volume of data?
So in terms of too much, I think one of the things that you're dealing with is perhaps state requirements in terms of too much. For a lot of the public health uses of data, there are specific carve-outs for public health, for example, when they hit the privacy and security rules in the federal regulations. Mm-hmm. Now, it does mean that if you get more data than you've been dealing with, you do have to secure that. And so it might be more challenging in terms of having information systems that are more secure if you've got more information. There are ways in which you can, in, say, the HIE space, take advantage of information that is being shared in the HIE and transform and filter the information down to the level of information that you've been getting. And so there are ways to address that so that you're not getting more than you need, more than what you consider to be the minimum necessary. Not that minimum necessary applies to public health in that particular context. So from my perspective, too much is a problem that can be readily solved. And more often than not, the problem that I keep hearing is that we can't connect. We can't get people to give us anything. And so if your problem turns into something of, well, this is more data than we have to deal with, Moore's Law is on your side, as are there are numerous solutions for dealing with filtering the data down to something that you can deal with. Yeah, I agree with Keith on that. I mean, it's a filtering issue. In 2.x messaging, typically there's a massive amount of transactions that flow, say, in a hospital enterprise that are filtered out for public health purposes. You never see most of that. You see only a fraction of it that is routed to public health, for instance, for laboratory reporting, for ELR, for instance. But again, that's because it's being filtered out for you already. Because of the nature of the CDA bucket, you can pour an awful lot into that single bucket. So there's still the issue of filtering it, like he said. You can filter it down to what you just want, but that somebody's got to do the filtering. And whether that filtering is done prior to that being transmitted to you or after you get it, puts the burden on somebody. But filtering is the answer.
So this is Sandra. This is Sandra from IBM. I want to speak on behalf of Karen, if that's okay. So you actually made a really interesting question, and I'm going to twist it about 90 degrees if I can, because I do think that as you're getting these reports, there are ways to break it down to just what you're looking for. However, what I've been hearing from the community is more concerns about how the number of reports that public health gets may increase significantly, because if you start to automate or put more automation into the process of public health reporting, you may be getting a lot more reports than you're used to. And so you need to have systems in place that will help the epidemiologists and the public health nurses and people who are really on the front lines expecting to respond to these reports, ways that they can really allocate their resources to where it needs to go, to prioritize the work that they're doing with that increase in reporting. And so I think that is a really good issue for public health to have. And but that's where I've seen more concern, I think, from the community.
Well, I think there are several different aspects of concern, and all of it relates to, it's change. It's different than we're used to, and until we're actually dealing with it, we won't know how much the volume really changes, and until we have the tools to do the filtering, we won't know how successfully we can filter down to just what we can deal with, and I think that there's an inherent, I think it was Keith who mentioned, the philosophical, just ask for the bare minimum that's needed to do the work. And I think that there's something philosophically different about using CCD and CDA, the big bucket that has everything in it already prepackaged, and it's actually epidemiologists aren't used to the fact that it's actually less work for our partners to send us everything than it is for them to do the filtering. We're used to asking for the minimum because it's less work. So I think we need to do some communication and some education on the systems that people are buying for certified EHR technology have these capabilities to send a CDA document built in, so we should, like as you guys said, take advantage of it.
Seth Selby here, and I apologize. There was a few minutes when I wasn't listening, and we are past the hour, by the way, so folks, everybody matters know at this point. There has been a lot of discussion about the use of templating as a way of essentially using the CDA and then constraining it in a way so as to filter the content for a particular use. That appears to be one of the attractive elements of CDA that I don't hear talked about very much when we talk about 2.x messages. And I'm wondering if that's just because I'm not hearing the right people talk, or because the same concepts actually are applied but using very different words.
Seth, this is Austin. It's the latter. In my presentation, I talked about message profiles, and those, in fact, are about constraining the message. Templates in CDA context are about constraining the message and binding it to particular vocabularies and applying basically the same sort of constraints I talked about, optionality versus cardinality, and vocabulary. So the concepts are very similar, the names are just different. But the end result is the same. You've got a message that is general, that is constrained to a particular use case and a particular set of data that you want.
Hi, this is Tom Shimabukuro again with the Immunization Safety Office, and I just sort of a general question. They kind of reflect my lack of understanding of the difference between HL7 and CDA. But if I'm a public health person and I'm using or I'm managing a surveillance system, and it's really an event-driven type of surveillance system, so it's not a longitudinal thing. You're not following people over a course of, years or whatever. You're not following them long-term. So really, you're looking at, events or observation are in rows, and then you've got variables as columns. If I have a way of generating the proper variables for each event, whether they're coming in by HL7 or CDA, does it really matter to me how these organizations are sending data, whether it's HL7 or CDA, or what? Like, why would I, if I have a way of converting this to the database I want, whether that's SAS or Excel or whatever, why does it really matter to me as the end user?
What matters to you is you get the data. I think the key point that I've been trying to make about using CDA is taking advantage of capabilities that means that you're going to be able to get the data. Because they're capabilities that are built into products as opposed to interfaces that have to be developed to get at specific data.
So is it more efficiency and ease of getting the data? Just a more efficient way, a better way of getting the data, as opposed to just getting the data, period?
Well, of course, in the CDA, there's a requirement that this is set, that the data you receive includes some data that could be interpreted by a human reader. That can, if I understand correctly, be built into HL7 not required. That's one way in which that affects how you might use the data.
Hi, no, Mark. I would answer you a slightly different way. I would say you're absolutely right. As a user, you shouldn't care. The reason you have the luxury not to care is because people like us are trying to work out all of these horrible nitty-gritty details about how to make it so that you don't have to care. So someone has to work out those nitty-gritty details, and there are various ways to do it. That, I think, is what we're struggling with.
Okay, that makes sense to me. And I wasn't trying to minimize the effort that you're going through. I was just wondering from my perspective, when I ask a statistician to download a SAS data set and do some data mining or run an analysis, really from my perspective, it doesn't matter how that data gets into the database, just that the proper data gets in, whether it's through HL7 or CDA, correct?
Right, but someone's got to work out the details, that's all.
I understand.
Okay, so we are several minutes past the hour. I appreciate everybody's time and attention, and want to say thank you again to our three speakers. Unless there are any final questions, go ahead and adjourn the call. Okay, great. Well, again, thank you to everyone for joining, and a special thank you to Austin, Keith, and Karen. Have a good day.